In this video, we're going to talk about factoring trig expressions and rewriting trig expressions as different things, not just simplifying them. For example 3, I want to factor the following expressions. So I'm going to start with this one. And what I need to be able to notice about something like this is that this is the difference of two squares. So I know this is the difference of two squares. And because it's the difference of two squares, I know that if I had a squared minus b squared, I could rewrite that as a plus b times a minus b. So here, in this case, the thing that's being squared first is cosine. So I know cosine of x is squared. And I'm subtracting what's being squared here is 1, so 1 squared. And if I have that, then I know I can break this down into two things, with cosine of x being the first thing in each parentheses and 1 being the second thing, and me having a plus in one and subtraction in the other. And this would be my answer for factoring. For b, I have sine squared of u minus 3 sine of u minus 10. And I know that this is ax squared plus bx plus c form, with a being equal to 1. And if I see that, then I know that I can use the diamond method. This is the diamond method that I can use. So I can say, okay, well, I need two numbers that multiply to negative 10 and add up to the coefficient here, negative 3. So I can say I need two numbers that multiply to negative 10 and add up to negative 3. And those two numbers are negative 5 and positive 2. So I can rewrite this as I have a sine of u minus 5 times sine of u plus 2. And that's it. And then if you want to check your work, you can just FOIL that and see if you get the same thing as you started with. And you would. Then I also have example 4. I want to rewrite this expression so it's not a fraction. First, or a strategy like talked about in rewriting trig expressions that we haven't used so far is multiplying by the conjugate, sometimes of the base, sometimes that will help. So I'm going to try to do that here. I'm going to multiply by the conjugate of the base, which is secant of x plus 1. So I'm going to do that, multiply by that in the top and the bottom, because remember, if you multiply a fraction, you have to multiply by a giant 1 so that you're not changing the value of the fraction at all. And so if I did that, I would end up with secant of x plus 1 all over, I have secant, when I do this through, this is the difference of two squares, that's why I multiplied by the conjugate. So I would have, I know if I multiply a plus b times a minus b, it's going to give me a squared minus b squared. So here I would have, if this is a and this is b, I would have a squared, which is secant squared of x, minus b squared, which is 1 squared, like this. And if I do that, then I'm going to notice that off to the side, I'm going to write, okay, well, identities that I could use here to rewrite this thing. I can say that secant squared of x and 1, if I see those together, it looks like that Pythagorean identity with tangent and secant. So the identity is tangent squared of x plus 1 is equal to secant squared of x. And this doesn't look exactly like this, like the side. I want to have secant squared of x minus 1 on one side of this equation. So I can get that by subtracting 1 on both sides. And I can say, okay, well, tangent of x is equal to secant squared of x minus 1. And then I know that I can take these two terms and rewrite them as this one term. And so that's what I'm going to do. I'm going to rewrite this as secant of x plus 1 all over tangent squared of x. So I just changed this denominator to be just one term. Then from there, I'm gonna use that another strategy in this list, which was to potentially split up a fraction into two separate fractions. Maybe that will help me here. So I have this one fraction here. I can separate this into two fractions. I can say I have secant of x over tangent squared of x plus 1 over tangent squared of x. And then I go from there. This, I want to try to rewrite. Think about this. Cosine, sine, cosine. I think I'm going to, from here, I just want to not have fractions. I know that 1 over tangent squared of x is going to be equal to cotangent squared of x. So I'm going to pull, I really don't want to have fractions, so I'm going to pull secant of x out, and I'm going to write this as secant of x times 1 over tangent squared of x plus 1 over tangent squared of x. And then off to the side, I'm going to use the trig identity. I know 1 over tangent of x is equal to cotangent of x. And I can say, okay, 1 over tangent squared of x is equal to cotangent squared of x. So I can rewrite this as secant of x times cotangent squared of x plus cotangent squared of x. So I just changed 1 over tangent squared of x to be cotangent squared of x for both of those things. You cannot get any simpler than this. You can try, but you wouldn't get any simpler than this. So that's our answer. And then example 5, I want to use the substitution x equals 3 sine of u, and the fact that u is in between 0 and pi over 2 to express this thing as a function of u instead of x. So what I'm going to do is I'm going to say, okay, well, I have 9 minus x squared, and I'm just going to plug in 3. So I'm going to plug in everywhere I see an x, I'm going to put 3 sine of u instead. So I'll have the square root of 9 minus 3 sine of u squared. I just changed the x to 3 sine of u. And then from here, I'm going to have the square root of 9 minus, this is going to be, remember to distribute the 2 to the 3 and to the sine of u. So I'd have 9 sine squared of u. And then I know that I can take a 9 out, and I can write this as 9 times 1 minus sine squared of u. The point of that is not only to get a perfect square by itself, but also because I see 1 minus sine squared of u, which is going to be part of a Pythagorean identity that I can use a Pythagorean identity to simplify that. So I can rewrite this as the square root of 9 times the square root of 1 minus sine squared u. And then I know this is 3, and 1, if I off to the side talk about the identities, I know that I can say that I see 1 and sine squared of u together, so I could probably use cosine squared of u plus sine squared of u is equal to 1 to rewrite this. I can get 1 minus sine squared of u on one side of this equation by subtracting both sides by sine squared of u, and I would get cosine squared of u is equal to 1 minus sine squared of u. And then I could say, okay, well, I can take these two terms and write it as just this one term. So this that I have here, I'm going to rewrite as the square root of cosine squared of u instead. And I can simplify this further, and I could say, okay, well, I have 3 times the square root of cosine squared of u is just cosine of u. This is one term, and I'm finished, and that is my answer.